Today's notes are on properties of transformations. We're about to play a game, but first we need to review the three types of transformations that we've learned. The first one was a translation. In this instance, it slid from left to right. Notice the arrows pointing to the right, and my object remained upright. The top corner is still in the top corner. If you'd like to write a remainder to yourself, I'm just going to write slide. I'm going from this one to this one, and it stayed upright. The next one we learned was a rotation. In this instance, it's going to spin on its side. So notice how here, this was my top, and now it's rotating over there. Or what was my short side was on the top in this one, but over here, now it's on its side. So if you notice that any shape is no longer facing the same direction, I've turned it on its side, that's a rotation. Okay. You can measure specifically from one corner of the shape to the other corner of the shape the number of degrees that is rotated. But the ones we looked at, they were all 90 degrees. So it had that little box there in the corner that they were 90 degrees. And the last one was a reflection. So in this case, the top was still the top, but my shape flipped over. So it was the bottom left is now to the bottom right. So my reminder to myself is that I flipped the shapes. The distance is still the same, so from this corner to the same corner, notice how these two are far apart, or these two was close to the line, so on the other side it's close to the line, but my shape was here, and then it got turned over to the other side. Alright, so what is true about all the angles of the transformations above? Well, did any of my shapes change in size? No, they either slid across, they turned, or they flipped over, so they're all the exact same shape, so my angles still stay the same. Right? It hasn't gotten bigger or larger. My angles are still the same as what they were. Same thing with my side lengths. Okay. Side lengths stay the same. And all of the ones where we've created them, either we've drawn on a coordinate grid, or we drew them with our protractor, this side length is still the same in every picture. This length remained consistent. Whether I flipped it, I slid it, right, or I turned it on its side, that bottom length was still always the same. Therefore, the translation, rotation, or reflection always create congruent figures. Okay, we've mentioned that a couple of times this year so far. So unless there's a scale factor or a dilation that'll make it bigger or smaller, these are congruent, meaning they're the exact same shape. The angles stayed the same and the sides stayed the same. Whether they slide, rotate, or flip, all of your shapes today should still be the same.